Hello, pre-calculus students. We're going to work on section 2.1 today. Please notice that it actually is separated through two packets. So the new one that I handed out on Thursday says section 2.1 functions, and then we're going to continue on to the page that included section 2.2 that says word problems. So starting with this one, our objective in this section of the notes is to determine if a relation is a function, find the domain, evaluate functions, and calculate net change. So here's a reminder that a function is a relation between two variables so that each input has at most one output. That's the definition of a function. A relation sends inputs to outputs, like you could send apples to caramel and peaches to peanut butter, although that sounds a little odd. And that would be a relation. It would also be a function, but a function has the extra condition that every input has at most one output. And I'm sure you remember that you can determine if the graph of a relation is a function if every vertical line passes through at most one point. So it fails if you can find a vertical line that passes through two or more points. A domain is a description of all the values that x can be. A range is a description of all the values that y's can be. So if you're going to find the domain of a function, we already talked about this, so I'm going to go through it kind of quick. There are three things you have to be careful of. If you are taking a square root or an even root, the expression under the radical, which is called the radicand, has to be greater than or equal to 0, otherwise you get an imaginary number, not a real number. So the domain would be the expression that satisfies that condition. If you have division, you can't divide by 0 and get a real number, so the denominator cannot be equal to 0. So that would give you restrictions on the domain. And if you have a log, the argument of the log, the expression inside, has to be greater than but not equal to 0, or the log is undefined. So let's look at the first example. So we have y squared minus 3 equals x. Is it a function or is it not a function? So we can do this in two ways. We can do it algebraically. So I would solve for y. So add 3 to both sides, and then take the square root. And anytime you take the square root of a square, you get y equals plus or minus, because we took the square root of a square. So you can see by the equation that if you plug in a value for x, whatever this expression becomes, your outputs are going to be the positive of that number and the negative of that number. So one input gives two outputs. For example, if I put in x equals 1, I would get plus or minus the square root of 4, which is plus or minus 2. So 1 gets paired up with 2, and 1 also gets paired up with negative 2, so that fails the definition of a function. So it's not a function. Graphically, if you can graph it, you can perform the vertical line test. So if we move the 3 to the other side, now this is an equation in standard form of a parabola. Lost my thoughts for a moment. So this shifts it to the right by 3, and it opens sideways because the y is quadratic, and it's going to open to the right because the a is positive. So this is what that function looks like. You can tell that we can draw a vertical line through there, and there's one input, whatever that number is, that goes to two different outputs. So that fails the vertical line test and is not a function. We have had extensive conversations about interval notation, so I'm just going to put a little brief thing here. So we always go left to right, least to greatest. Open parentheses mean not included. Square brackets mean that value is included. more than one region is joined by a U-frig union. All right, great. And you know that infinity is not a fixed number, so it always gets a curved bracket. So let's find the domain.
Hello, my name is